Greetings and salutations, young true believers. So, in the last video, we talked about formulating causal hypotheses. Today, we're going to talk about confirming causal hypotheses. So, there are three primary methods for confirming causal hypotheses. We'll talk about those in a moment. But we'll start with this discussion. This is on page 372 of the text. Confirmation of many cause and effect hypotheses, consists in trying to show that the hypothesized cause is the condition but for which, now there's a Latin term for that you're going to encounter quite often, conditio sine qua non, right? It's the condition but for which the effect in question would not happen. So the example from the text is, we dried the floor, turned off the toilet and waited. The floor stayed dry. Then we turned the toilet back on and we watched. Now there's a puddle on the floor. Therefore, the leaking toilet caused the puddle, right? So the hypothesized cause is the leaking toilet. The effect in question is the wet floor. And the argument gives a reason for thinking that, but for the toilet, the floor would have stayed dry, right? So we're looking for the conditio sine qua non. It's going to confirm our causal hypothesis, right? This caused that, right? X caused Y. So the primary method for confirming a causal hypothesis is what's known as the randomized controlled experiment, right? A randomized controlled experiment is one in which subjects are randomly assigned, and that's extremely important, right? Randomly assigned to either an experimental group E or a control group C, which differ from one another in only one respect. Subjects in the E group, the experimental group, are subjected to the suspected cause, right? So here's the example from the text. In an experiment, 50 willing volunteers were infected with the cold virus and then randomly divided into two groups. The subject in one group were given a Zicam treatment as per the instructions on the box. 2 weeks later, the number of people with colds in both groups is compared. 18 of the subjects who had not been treated with Zicam had colds, and only 10 of the subjects who had been treated with Zicam had colds, a difference that is statistically significant at the 500th level. Therefore, Zicam probably reduce the frequency of colds in the experimental group, right? So what does it mean statistically significant at a 500th level? So there were 25 subjects in both the experimental and control groups. 40% of the experimental group, which is 10 out of 25 people, caught colds, and 72% of the control group, those who weren't subject to the Zicam treatment, 18 out of 25 people caught colds. So this is why you psychology and sociology students are ever wondering why you have to take stats. This is why you have to take statistics, right? So according to statistical mathematics, a difference this large, which is 32 percentage points, is statistically significant at the 500th level, which just means that there's a 95% chance that it's not due to chance, right? Now, 95% is obviously not 100%, but if you knew, for example, that there was going to be there was a 95% chance of rain, you would definitely take your umbrella. All right, the second method for confirming a causal hypothesis, the prospective observational study, right? So what is a prospective observational study? In a prospective observational study, two groups are compared as to the frequency of something, right? Really straightforward. So what's going on? Here's the example. Does partying on the weekends adversely affect academic performance? Students at San Diego State University were surveyed about their weekend study habits. The academic performance of 100 students who identified themselves as attending parties on most weekends was compared to that of 100 students who said that they rarely or never attended weekend parties. It was found that 60% of the partygoers had grade point averages below the mean for all San Diego State University students. Only 30% of the students who said they rarely or never attended weekend parties had grade point averages below the mean. Therefore, attending weekend parties probably adversely affects a student's academic performance. Now, so what's going on? All the members of one group say that they have the suspected causal factor, in this case, attending parties on most weekends, and none of the members of the other group say they have it. A significant difference in the frequency of the effect, low grade point averages, in the first group is unlikely to be due to chance. But we can ask, and fairly ask, are the two groups really comparable, right? So this is where a phenomenon known as confounding or lurking variables comes into play. A confounding variable, right, is a variable that the researchers cannot control for or predict, right? So For example, the partying group may contain a disproportionate number of freshman students who live in the dorms, and it may be that noise and distraction and homesickness, right, are driving down their GPAs, right? Lastly, the retrospective observational study. Now, you might have guessed from the name retrospective, we're looking backwards, right, at a suspected causal factor. So what's going on here? In a retrospective observational study, one reasons backward from a phenomenon of interest to a suspected cause or causal factor. So going with our example of the San Diego State students, does partying on the weekends adversely affect academic performance? Students at San Diego State University were surveyed about their weekend study habits. It was found that of 100 students on academic probation, 60% identified themselves as attending parties on most weekends. By contrast, only 20% of 100 students not on academic probation identified themselves as attending parties on most weekends. Therefore, attending weekend parties probably adversely affects a student's academic performance. Now, in one comparison group, all the students are on academic probation, and the other group, none are. The only thing that could account for this difference if the comparison groups are otherwise the same, and again, this issue of confounding or lurking variables comes into play, right? We can't be absolutely certain that the two groups really are comparable. The only thing that could account for the difference is that most of the former groups said that they attended parties on most weekends, right? Again, are the two groups really comparable? So it's very difficult to predict the lurking variables, the confounding variables, right? So prospective observational studies and retrospective observational studies offer a weaker form of causal hypothesis confirmation than do randomized controlled experiments. And that's why randomized controlled experiments are the proverbial gold standard for confirming a causal hypothesis.